This is a Data 620 minicomputer from 1965, and this is an ASR33 teletype, and these two combined create a complete system because the teletype has a paper tape punch and a paper tape reader on it. Unfortunately, they're both in very rough shape, so we have a massive uphill struggle ahead of us. This ASR33 teletype was graciously donated by my good buddy John, and he probably knows more about teletypes than anyone alive today. He actually flew down here a couple of months ago to help me get the Model 14 and Model 15 teletype up and going, and in just 2 days we brought both of those machines back from the brink. So if John says that this ASR33 is mechanically sound, you can bet your bottom dollar that it is mechanically sound. Unfortunately, cosmetically, it's in a bit of a state. These ASR33 teletypes are notorious for having plastic that just turns to dust after the years, and you can see this one has fallen victim to that. So we're gonna need to come up with some interesting ways to figure out how to make this thing look the part again. But that's all gonna take backseat to this big boy up here. And this Data 620 minicomputer was also donated by the legendary Godfrey. So Godfrey, if you're watching, thank you so much for this. And it's been lurking around in the background for about a year and a half because it took me a while to get things set up in order so that way we could sit down and give this thing the time and effort that it deserved. And that's what we're going to start working on today. Now, it's important to note that this is not a Varian Data 620. This is a Data Machines Incorporated, or DMI machine. As I understand it, DMI designed the Data 620 from the ground up and built the entire thing out of discrete transistors and germanium diodes. And that's what we have going on inside of here. But ultimately, DMI was bought out by Varian. And Varian took the Data 620 design and converted it to 7400 series TTL logic. Those seem to be much more common because I can't find hardly anything out there about the original DMI Data 620 that is fully transistorized, other than what we have right here. And really all that I have is a brochure here, and it has the full instruction set in it, which is great. It means that we can sit down and we can write new software for this machine. But if the machine doesn't come up smoothly, and I am not expecting it to, troubleshooting it's going to be very difficult because we don't have any documentation. I did get some printouts for the memory system, but it's very, very incomplete. And I have a full manual for a paper tape punch and reader module that I don't have. So we're definitely starting on the back foot here. But top tier #1 priority with this machine is to fix these atrocious panel gaps. This has been driving me out of my mind for a year. And the rail system on the core memory here and the CPU up here is pretty janky. So I think we're gonna have to wheel this thing out into the center of the room and really get to work on those rail systems. If we can figure that out pretty quickly and get it looking much cleaner, I think the next step then is to pull out this front panel here because this contains the power supply for the CPU. And whenever you're starting work on a completely unknown machine, it's always safest to start with the power supply. Seriously, look at these panel gaps. This is just atrocious. Things are very misaligned, and we even have the core memory running into the side of the rack. Let's fix this. But first, we got to get this thing out into the center of the room. The center of gravity of this rack is not nearly as low as I would like, but I do believe this is how the modules would have originally been laid out in the rack. Let's slide the core memory out next, and already you can see a bit of the problem here. It gets stuck, which slides the whole rack around, and then I gotta fight it to get it free. Finally, with it all the way out, I can climb underneath it and remove the remains of the lower slider. And when this big orange furball says it's time for a break, it's time for a break, even if I only just got started. Anyways, requisite pets done, we can finally remove the full lower slide mount. It's just another 4 screws on the backside, and then it pulls right out. If you're looking at this thinking like, what on earth is going on? Like, don't worry, I think that's a pretty natural reaction to the way that this rack is designed. As it sits, there's 5 modules plugged into this rack. On the bottom, we have a memory power supply, then I/O, then we have the core memory, we have the front panel and CPU power supply, and then the CPU all the way up at the top. Now, the front panel and the 2 little ones down here on the bottom, they have regular rack sliders like you would expect. They bolt to the side of the rack and they slide in and out just like plain Jane, totally normal. But the core memory and the central processor up there, apparently DMI wanted them to be able to open like a book so that you could get to the back side of it, which I appreciate. This is like really, really cool. But this means that you can't have rack sliders that sit on the side. The sliders have to be on top and on bottom. And on top, you've got this really complex, fantastical slider. But on the bottom, all they did was just have this like super simple ball bearing slider, which has come apart decades ago. So I need to come up with some kind of new slider down here. Otherwise, the bottom side of this is just floating free, and you can see the whole thing can like rotate and twist, and it's just not great. So I got to figure out something for this in order to make this less terrible. I did quite a lot of hunting for a good rail, but it turns out rails that are meant to be used sideways like this are kind of rare. So this spare rail I have for a big hard drive will have to work for now. So to get the hard drive rail mounted, I need to punch some holes in the aluminum bracket. And actually the aluminum is thick enough that I can run a tap through these holes to make them threaded. Then I'll put the slider in place and cinch it down nice and tight. Fortunately, the screws in this case aren't load bearing, so any force should be in the vertical direction, which will push on the bracket itself, not the screws. The slider still needs to be attached to the core memory unit itself though, and for that I'm using this piece of scrap metal I had hanging about. And you can see the slider sticking off the bottom here, so let's thread the needle and get the rest of the ball bearing slider in place. And to get this all cinched down proper, I need to get the front panel out of the way. We'll be working on this thing later. With the bottom rail sorted, I want to move the top mount up. I'm going to do that by stuffing some stacked washers between the mounting bracket and the rail itself. I'm also going to add a few more washers to the left side to hopefully align the whole thing a little better. This rack is not a great rack at all. In order to get the holes to line up like I need them to, I gotta use this big screwdriver like a pry bar. But once it's all cinched down tight, it stays in place. So let's slide that front panel back in and see how we did. I mean, that's not perfect, but it's a far shout better than it was. The gaps are not actually balanced from top to bottom, but they're consistent from left to right. And that was the thing that was really bothering me. Now, there is still a panel gap between the core memory and this unit right here. Unfortunately though, it's not a full height of the little adjustments on the rack there. So if I lower it down by 1 hole, then these two collide into each other. And if I move it up, there's a large gap. I'm probably going to tweak on that a bit more in the future. However, for now, I think it's time that we dig into actual components of this machine, starting with the front panel here. Now, all this box is a front panel and the power supply for the CPU. And because it's the power supply for the CPU, it weighs an absolute ton. It's also disgustingly filthy. So we've got a ton of cleaning to do on this thing, and there's a bunch of very big gnarly capacitors that I think are going to need to be checked out as well. So I'm going to try and pull this thing as far apart as I can so we can get in there and really start scrubbing things up and hopefully give those capacitors a little bit of a health check. This thing is not a pretty sight, so let's get to work cleaning it up. The rails are just going to get in the way, so let's remove those first. Then the front plate looks to be just bolted on with 7 bolts around the periphery. With all those removed though, it isn't quite ready to come off. We need to flip this whole beast over onto its side so we can get to the bottom. The problem is the buttons along the bottom edge of that front panel. They're soldered into wires, but also attached to the front panel itself. They have to be pushed forward. Then the atrocious and mostly broken plastic mount pieces can be removed, and then the switch can be pushed back through the front panel until it's free. Finally, after all of that, the actual front panel plate can be pulled free. And look at all the buttons. These things are just absolutely awesome. Well, awesome for now. We'll see how I feel a little later. Anyways, looking at the underside, the bottom is surprisingly clean. No massive corrosion or broken wires or anything. Even the wire wrap on the bundles still looks to be hanging in there. It shouldn't take hardly any cleaning under here. Let's get a closer look at those buttons though. The connector on the back can be removed super easily with just 2 push locks and then carefully prying it out until the whole thing breaks free. We can just see the large toggle switch and transistors in there, but here's where it all goes downhill. These things are riveted in. If a bulb goes bad and it needs replacement, you gotta drill the rivet out and replace it with a bolt, as you can see has been done multiple times here before. This is a crime against field engineers. Moving on before I blow a gasket at that design, let's get these capacitors out. Each capacitor is held in place with 2 mounting screws through the metal clasp. It's tedious work to get them out because the nuts aren't captive on the backside, and access to them is quite limited in some cases. I also made sure to make careful markings of their orientation to make sure that I don't install any backwards during reassembly. Although, these things are gross beyond belief. Just look at all the crustiness on there. Except if you look closely, the crustiness is centralized around the positive terminal. I don't think this is electrolyte leaking out. I think this is something else, like animal urine crystallizing around the positive terminals. Yes, these capacitors were absolutely disgusting, but also these capacitors are made by Sprague, and if I've learned anything, it's to never underestimate a Sprague cap. This is the first time any electricity has been put into this cap in like 40 years. So let's go ahead and plug my bench power supply in. I'll turn the voltage all the way down. Okay, look at that. We're already at 2.3 volts pulling 0 current. Let's just bump this up a little bit. So we went up to 10 milliamps, 20 milliamps. As I bring the voltage up, it's just taking it. 20, 30 milliamps. There's 10 volts, 0 milliamps. That's a good capacitor. Now this one's rated to 25 volts DC, so let's keep going. Let's see if we can get on up to 20 volts here. As I crank it up a little faster, we're seeing like 20 milliamps, 30 milliamps. Which is, I'm sure Shelby was losing his mind with how much current I'm dumping into this thing. Nobody's gonna believe me, given the state that they were in, but honest to God, I never tried reforming this before. This is the first time any energy's been put into it. It's good. I bet you they're all gonna be good because Sprague is just killer. The final step here is going to be cleaning up the main chassis. It's absolutely filthy. And seeing the amount of corrosion present on exposed iron, as well as on the aluminum bits themselves, really reinforces my thinking that this was a latrine for a host of small animals. Urine is incredibly corrosive. After years and years, the smell may fade, but the corrosion stays. Don't worry, I've donned a mask to do this nasty work, because regardless of what caused the corrosion, we gotta clean it up anyways. The wire brush makes excellent work of breaking the worst of it apart. I just need to go back and forth, cleaning as much as I can without damaging the underlying metal or components. Periodic hits with the air hose helps clear the detritus and lets me see how this thing is shaping up. After the wire brush, I went back over everything with a Scotch-Brite pad. And when in doubt, use more Simple Green. The looms on the backside here were filthy as well, so a plastic bristle brush and Simple Green helped get them much cleaner. Moving around to the front side, I'll use the same technique. Spray the buttons down with Simple Green, scrub with the plastic brush, then wipe clean and dry with a shop towel. Of course, I went through with the air hose later to blow out any excess Simple Green left behind. Now let's get that front panel cleaned up, since it's the face of the machine, starting with a razor blade on the leftover residue from a sticker that fell off decades ago. Then more Simple Green and a deep scrub to really get the gray paint clean. It's already shaping up to look brilliant, but those pull rails on the side are looking way too dingy. Fortunately, they're just exposed aluminum, so the Scotch-Brite pad here is the perfect tool for the job. And in just a few minutes, they're cleaned up and looking brilliant. Then let's pop the front panel back on. And this was actually way harder than it sounds. Nothing wanted to line up perfectly, and it actually took me like 10 to 15 minutes of faffing about to actually get it on. Given the state that it was in, this thing turned out amazingly well. I mean, first of all, I'm not afraid to touch it without wearing gloves, but the front plate here cleaned up and looks almost brand new. Same with these little rails after I was able to brush them and get them looking nice and clean. The little buttons on the front here look stunning now that I've gone through and cleaned each one of them up individually, and this thing is going to look out of this world with all of the lights blinking and flashing. Even the capacitors all came back totally fine. I put every single one of them on the bench power supply, and in less than 5 minutes, they were drawing 0 current at 23 volts. Absolutely stunning. There is still one problem, and it has to do with these buttons down here on the bottom. The way that these things go in is they have these little plastic pieces. I've got the remnants of one of them right here, and after the years, these have all broken and fallen apart, and I think I'm gonna have to design these up and 3D print new ones, because right now I've got them just kind of like sitting in there. But if you were to push any of the buttons on those, I think they're gonna fall apart. So it looks good now, but that part is currently totally unusable, and that's something that we'll get into in the future. But aside from that, I think this thing is pretty much ready to go. We could put power into it and see what DC voltages it's punching out, but there's a problem with that. And if we take a look at the backside, that problem becomes abundantly clear. It's a little hard to spot, but if you look super close, you'll notice there's no AC plug. We can't actually plug it in, and that seems wild and insane. Surely one of these must be AC in, but there's 9 pins in each one of these connectors. So clearly it's not just AC. There's something deeper going on here. And in order to understand that, I think we need to slide this thing back into the rack. We're looking at the back side here, and this is actually the back of that front panel unit that we just slid in. And first of all, I know that the 5 modules are in the correct order because they have a serial number. This central processor at the top is 5004-1A. The front panel is 5004-1B. The core memory is 1C. The I/O is 1D, and the memory power supply is 1E. So we are in the correct order that way. Now looking at the back here, there are 3 main type of connectors that we come across. There's these big square ones. I have absolutely no idea what they're called, but they're clearly being used to move data and signals between the processor, the front panel, the core memory, and I/O. Now on the I/O, we have a smaller version of those big ones, and I think these are connections to external peripherals. So if we have a teletype, it's going to connect into one of these. And then we have the crux of the problem here. We have these round kind of twist lock connectors. I'm pretty sure these are made by Canon. And the front panel has 3 of them, the central processor has 1, core memory has 2, the I/O has 1, and the memory power supply on the bottom has 3. And how do all of these connect to each other? Well, if we look a little closer at the memory power supply down here on the bottom, we get a kind of a clearer idea of what's going on. This does have 3 of those big round connectors here, but in between them is this frayed nightmare that used to be an AC cable, and then there's also a little toggle switch right here. So AC only comes into the memory power supply, and then from here certain voltages are created and sent to the core memory itself, and I believe AC is also passed through one of these big round connectors up to the front panel where it makes the rest of the voltages for the CPU. And the reason that I believe that is that at the very beginning of this episode, I said that we do have some documentation for the memory system. And among that documentation, there is just like 1 or 2 schematics, but it just so happens that one of those schematics is the full schematic for the memory power supply. In that schematic, I can see that AC does indeed come in through here, and then it goes to J1, J2, and J3. And looking at the signals that come out of J1 and J2, I do believe that both of these are dedicated for the core memory, which means that J3 here is dedicated to the front panel. Now, if we look at J3, there's a lot going on. There's chassis ground, which is a pretty easy one. It's also got common. This is just the ground return for all of the DC rails. Then we have a minus 12 volt DC and a reset, and these are super confusing. I tried following them around and I can't make a whole lot of sense out of them. Then we have a reset lamp and a power on lamp. These are pretty self-explanatory. And then we've got 115 volt AC switched and not switched. And this is just a little too complex for me to feel comfortable trying to power up this front panel by itself. So I think the proper order of operations here is going to be to pull the memory power supply out next, tear it down, get it looking nice, bring it up by itself, and then plug it into the front panel and bring the two of them up at the same time. That should bring our full power supply up for the memory and the processor, as well as I/O. And there's even more problems with doing that, because even though we have the schematic for the memory power supply, we don't have any schematics or wiring diagrams for anything else. So on the front panel here, I don't know which one of these three goes to the memory power supply to take the input, or which one goes to the processor and which one goes to the I/O. But I have a little wiring map that I'm kind of building up here, and as I learn more, I'll write them down, and by process of elimination, it should get easier and easier to figure out what's going on. Now, as for which data cables plug into what, that's a problem for future David. I'm not even gonna try and think about that today. So even though we didn't throw any electrons into anything today, except for those gnarly capacitors, I think we got a really good first step going on this Data 620, and I'm starting to get really excited about it, especially now that we have this schematic for the memory power supply. So in the next episode, we're gonna pull that memory power supply out and get to work on it, and we should hopefully see some sparks in that one. So I wanna thank you all so much for watching, and I hope to see you in the next one.